Hey there, developers. Want to level up your skills and create dynamic, interactive web applications that will wow your users? You have come to the right place. In this tutorial, we are diving deep into one of the Angular's most powerful features, directives. We will explore everything from the built-in directives Angular provides out of the box to writing your own custom directives to supercharge your HTML with custom behaviors. We will explore everything from the built-in directives Angular provides out of the box to writing your own custom directives to supercharge your HTML with custom behavior. But first, what exactly are directives in Angular? At their core, directives are classes that allow you to extend and enhance DOM elements. They let you package up functionality to reuse across your application. Angular has three main types of directives. First one is components. These are the directives with a template. Components are the most common type of directive and form the building blocks of your UI. Next one is attribute directives. These change the appearance or behavior of an element, component, or another directive. We will see some examples of these soon. Next one is the structural directives. These directives offer the DOM layout by adding and removing elements. They can shape and reshape your page structure. So why are directives so important in Angular development? Well, because they allow you to write cleaner, more maintainable, and more reusable code. With directives, you can take common UI and behavior patterns, package them up, and use them effortlessly across your application. Directives are also key to working with and extending Angular's template syntax. You can create custom HTML-like elements, loop over data to generate DOM elements, and conditionally show or hide elements. The possibilities are endless. So if you are ready to master art of Angular directives and take your apps to the next level, stick around. Throughout this tutorial, we will be working with the latest and greatest version, Angular 17. We will start with built-in directives and work our way up to writing custom ones. By the end, you will be directive guru. So let's get started. Let's dive deeper into understanding exactly what directives are in Angular. As we mentioned, directives let you extend and enhance HTML elements in the DOM. You can think of directive like a special instruction or command in your HTML that tells Angular to change or modify an element in some way when it renders to the template. Angular provides three main types of directives that are core to how to build templates and user interfaces. So let's break each one down. First up are components. Components are directives that always have a template. They form the basic building blocks of an Angular application's user interface. Your Angular app will have a root component, and inside of that you will nest other subcomponents to build out a full user interface. So components are the most frequently used type of directive. Next are the attribute directives. Attribute directives are used to change the look or behavior of a DOM element. They are usually applied as attributes to elements. For example, Angular has built-in attribute directives like ng-class and ng-style that let you dynamically change CSS classes or styles on an element. You can also define your own custom attribute directives to encapsulate any DOM manipulation you need. Finally, we have structural directives. Structural directives are used to reshape structure of the DOM by adding, removing, or manipulating elements. They generally operate on an element and its descendants. Angular has built-in structural directives like ngIf, ngFor, and ngSwitch for rendering elements. For conditionally rendering elements, looping over lists to generate elements, and more. The asterisk syntax before the directive's name indicates it's a structural directive. Those are the three types of directives you will work with Angular. Through directives, you get a very expressive way to write templates that go beyond plain HTML. Directives allow you to invent new HTML syntax specific to your application needs. You can create directives that express complex UI patterns in a readable, declarative way right in your templates. Moreover, directives let you encapsulate common behavior in a reusable package. That means dry, maintainable code. You can write a directive once, then apply it anywhere you need that functionality. Directives are also deeply integrated into Angular's template system and work seamlessly with features like data binding, change detection, and dependency injection. That makes directives an indispensable tool in your Angular tool belt. Next up, we will start looking at some of Angular's built-in directives you are likely to use in regular basis in your own apps. While Angular allows you to write your own custom directives, you don't always have to. Angular comes with a set of very useful built-in directives that you will find yourself reaching for often. So let's check out some of the most commonly used ones. First up, we have the attribute directives ng-class and ng-style. These directives let you dynamically modify and CSS classes and inline styles on an element. With ng-class, you can pass in expression that evaluates to an object. The keys are CSS class names and the values are booleans indicating whether that class should be added or removed. So for example, look at this code example. We have a div that has the ng-class directive on it, and we are adding some classes based on some conditions. So in this case, the active class will be added if isActive is true, and the text danger will be added if hasError is true. So this is super handy for applying styles based on component state. Similarly, ng-style lets you set inline styles dynamically. You pass it an object where the keys are style names and values are style values. So here in this example, this sets the color and font size styles dynamically based on the component properties. So this text color and font size is coming from the Angular TypeScript class of the component. Great for data-driven styling. Next, let's look at the ng model. This is a special directive for two-way data binding, which is mostly used with form elements like inputs, selects, and text areas. With two-way binding, changes to the data in your TypeScript class are automatically reflected in the view, and user interactions with the form elements are automatically sent back to update the data. It keeps everything in sync. So here is an example of binding an input to a property using ng model. Any changes the user types into this input will automatically update the name property, and any changes to the name in the class will update the input's value. ng model also provides features for tracking form control state and validity, which is super useful for form validation. Finally, let's cover the big three structural directives: ngIf, ngFor, and ngSwitch. So ngIf is used for conditional rendering. It will only render the element and its descendants if the expression you pass it true. So the syntax looks like this, as you can see on the screen. So this is the most popular method for using the if condition in Angular, but in Angular 17 this is the latest method that you can use to add the if condition. You just have to add this and you can keep the div within the curly braces. So this is another way to do it. So this is an if-else construct right in your HTML. Next is ngFor, used for rendering lists of items. It repeats a template for each item in a collection. And the syntax is this. There is another latest way to do it in Angular 17. That is, you just add the for loop in this way. And here you will add item of items and track item.id and then add the list within that. So this will loop over the items array and render an li for each one. ngFor also provides some extra micro syntax like indexes, first, last booleans, and even odd properties. Lastly, we have ngSwitch, which is like the switch statement for your templates. You define a switch expression and a set of possible matches, and it will only render matching template. And this is how it looks like. There is also a latest way in Angular 17 to add the switch. You just have to add switch in this way, and within this we will add the case and finally default. So here these are the two methods that you can use any of these, but this one is the latest in Angular 17. So this is like an if else chain for template fragments based on the value of status. These built-in structural directives ngIf, ngFor, and ngSwitch are some of the most powerful tools for dynamically shaping the structure of your rendered HTML based on your application state and data. So that covers some of Angular's most useful built-in directives. With these in your toolkit, you can create dynamic, data-driven templates with conditional rendering, dynamic styling, list rendering, and more. Next up, we will dive into writing our own custom directives. While Angular's built-in directives covers a lot of common use cases, sometimes you need to encapsulate your own custom behaviors into a reusable package. So that's where the custom directives come in. Why would you want to create a custom directive? Well, there are a few key reasons. You have some DOM manipulation or behavior logic that you find yourself repeating in multiple places. Directives let you centralize that logic and reuse it via a simple directive interface. Second reason is that you need to do some complex DOM manipulation like adding, removing multiple elements or attributes based on some state. Directives provide a clean way to encapsulate this. Third reason is that you want to create a custom DSL, that is domain specific language, for your application's templates. Custom directives let you extend Angular's template syntax with your own abstractions. So how do we create directive? Well, Angular CLI makes it easy to generate the basic skeleton. You simply need to run this command ng-generate directive and the name of the directive. In our case, I specified the highlight. So this will create a file called highlight.directive.ts that you can see here, okay, with a basic directive structure. A directive has two key parts, the directive selector and the directive class. The selector is how you will apply the directive to the elements in your templates. It uses a CSS selector syntax. A good convention is use a camel case name prefix with your app prefix. So for example, in this you can see we have the app name. In our case, our app name is app, so that's why it has prefixed with the app. So this selector would match any element that has the app highlight attribute. The directive class is just normal TypeScript class but with the directive decorator applied. This is where you will implement the directive's behavior. The class can have a constructor which is used for dependency injection. This lets you inject services or other dependencies that the directive needs. The class can also implement lifecycle hooks like on init and on changes. These let the directives react to changes in the host element or in the directive's own input. Speaking of interactive with the host element, directives have two powerful decorators for this. First one is the host binding and second one is the host listener. Host bindings lets you bind properties of directive class to properties of the host element. For example, this is how you will add the host binding. You have to import it from the Angular core. Once you add it, you can use it. So in this case, this binds the directive's BG color property to the host element's background color style. So whenever BG color changes, the host element's background color will update automatically. Next, we have the host listener. We have to import this as well from the Angular core. So this listens for the mouse enter. Next, we have the host listener that lets you listen for the events on the host element. So for example, this is the code that you can see. You have to import it as well from the Angular core. So this basically listens for the mouse enter event on the host element and sets the BG color to yellow when it is triggered. You can also use the another host listener with the name mouse leave on mouse leave. So let me quickly show you how to use it. So for example, I want to use it in the app component of TS. As I'm using Angular 17, I will directly import it in the imports array, highlight directive. In this way, once it is done, you are able to use it. So now let's go to the app.html, and here let me add a div hello xyz, and here you can add app highlight. In this way, now this directive is applied. Now let's run our project by running the command ngserve -o. It will build and open the browser automatically. So you can see that the hello xyz is visible, and also the styles have been applied. So let me reload it, and right now you can see that the background color is not applied yet, but if you hover on it, then the color would be applied. But if I leave my mouse, nothing is happening because I have to correct it. Here I will add the background color transparent if you leave your mouse. So you can see if I hover my mouse on it, it will add the color. If I leave my mouse, then it will remove the color. So here we are adding a default background color. So maybe I want to add red background color. If you add it, then by default it will show the red color. If you hover, then it will show the yellow. If you leave the mouse, then it will set it to transparent. So you can see how directives let you package up this kind of reusable behavior into a neat directive package. And here the directive, decorator, selector, host bindings, and host listeners are the key ingredients in creating your own custom directive. Next up, we will dive even deeper into some advanced directive techniques. So in this section, we are going to dive into some advanced techniques you can use with Angular Directive to supercharge your templates even further. First up, let's talk about using directives together. Did you know that you can apply the multiple directives to the same host element? This opens up some powerful possibilities. When you have multiple directives on a single element, they execute from the outermost directive to the innermost. This means if you have directive that manipulates the host element itself, it will run before the directives that just deal with the element's properties or events. You can use this to your advantage by creating directives that work together. For example, you might have one directive that adds a certain class to the host element and another directive that reacts to that class being present. Directives can also communicate with each other and with each other more directly. One way is via the host element itself. Directives can read and write the properties on the host that other directives can then access. Another way is via a shared service. Just like components, directives can inject services. This allows directives to share data and functionality via common service. So this is an example of how you might use a service to communicate between directives. You can see, so this is just to give you the imagination of how we will use in the real world. So this imagine this is a service. This would be in a separate file, and we have the data and getter and setter. Then we have a directive, and so this is our first directive and this is our second directive. Here directive A sets the value on directive communication service when its host element is clicked. Directive B can then read that value when it initializes. So this is just one pattern for directive communications. The possibilities are endless. Next, let's talk about creating your own structural directives. Remember, structural directives are the ones that modify the DOM itself by adding and removing or replacing the elements. Creating a structural directive involves working with Angular's template syntax. So the key thing to understand is the asterisk syntax, that star before the directive name. Under the hood, the asterisk is the shorthand for using an ng template element. Angular will wrap your host element in an ng template and then give your directive full control over when and how that template is instantiated. So let's create an example of custom structural directive that conditionally renders its content based on a Boolean input. So I'm going to create a new directive by running the command g generate directive, and I will give it name if true. Press enter. Okay, the directive has been created, and now here I will, in the constructor, I will inject some services like private template ref. Template ref, make sure to import it from the Angular core, and then we have the private view container, and import the view container ref as well. After that, I will create an input like this. Make sure to import it from the Angular core as well, and give it setter app if true, and we will define a function here that will receive the condition in this way, and then I will check if condition is true. Then we will add this dot view container dot create embedded view and pass the this dot template ref. In the else, we will call the clear function on the view container. So in this directive, we inject the template ref, which represents the content of the host element, and the view container ref, which represents the container where we can instantiate the template. The input setter gets called when the app. If it's true, we instantiate the template using the create embedded view. If it's false, we clear the container, effectively removing the content. So let's use this directive. For that, in the imports in the app component, I will add if true directive, and now in the HTML, I will add another div, and here I will use app. You can see it is available in the suggestion. So I will select this, and here I will pass the condition. So for example, if there is true, then it would be visible. Let me fix the alignment here in the flex direction column, and gap of 20 pixels. All right. So you can see that this is visible, but if I pass false here, then it will not be visible. So you can also use a dynamic variable from your TS file, like is logged in is equal to false, and use that variable here instead. For that, here I will add is logged in this double quotes, and now you can see it is not visible, but if you go back here and set it to true, then it would be visible again. So the structural directives can also provide a context to their templates. So this lets you pass data into the template that it can use during rendering. To provide context, you use the set method on view container ref and pass in a context object. The template can then access this context using the template variables. So for that, we have to change this line of code in this way. So this time you can see we are passing this template ref, and we are also passing a second parameter that is an object with the implicit condition. Okay. So in this version, we pass the object as the context when creating the embedded view. This makes the value of condition available in the template as an implicit variable. So you can use it in your template like this, and here let's add this. Okay. The as value syntax assigns the implicit context variable to a template variable named value, which can then be used in interpolation or other template expressions. Creating custom structural directives gives you a lot of control over rendering of your templates. With the static or star syntax, template ref, view container ref, and template context, you have the tools you need to create your own structural directives that can manipulate the DOM in powerful ways. That wraps up our deep dive into advanced directive techniques. With these tools in your belt, you are ready to create some truly impressive and reusable Angular directives. The only limit is your imagination. Now we will cover some best practices for creating directives that are maintainable, performant, and well tested. So let's dive in. First up, let's talk about naming conventions. While it might seem like a small detail, having a consistent naming scheme for your directives can make a big difference in the maintainability of your code base, especially as it grows. So here are some guidelines to follow. First one is use a consistent prefix for your directives. The Angular style guide recommends using a prefix that identifies your app or organization like app dash. This helps avoid naming collision with the third-party libraries. Use descriptive names for your directives. Next guideline is to use descriptive names for your directives. The name should clearly indicate what the directive does. For example, app highlight is better than just app color. Next one is using camel case for the directives selector and Pascal case for directives class name. This is consistent with Angular's general naming convention. So look at this code. A well-named directive might look like this. Next, let's talk about performance. Directives can have a big impact on your application's performance, especially if they perform a lot of DOM manipulation. So here are a few tips for optimizing directive performance. First one is minimize DOM manipulation. Accessing and modifying DOM is expensive, so try to batch your update and avoid unnecessary changes. Use host binding to modify the element properties directly instead of using the render to when possible. Use efficient change detection strategies. If your directives data doesn't change often, consider using the onPush change detection strategy. This tells Angular to only check for the changes when the directives input change, rather than on every change detection cycle. Just be careful not to mutate your inputs. So here is an example of directive that uses these techniques. In this directive, we only update the content when the data input changes, and we use the host binding to set the text content directly, avoiding unnecessary DOM manipulation. Finally, let's talk about testing. Just like any other part of your Angular application, your directives should be thoroughly tested. Angular's test bed makes it easy to write unit tests for directives. So here is a basic structure for a directive test. You can see this is the simple test component class with the implementation for the testing. In this test, we create a test component that uses the directive. Then we assert that the directive has had the expected effect on the host element. If your directive has dependencies, you can mock them using Angular's dependency injection system. Just provide the mock in the testing module. Like this, we have provided the mock service here. So this allows you to test your directive in isolation from its dependencies. And that's it. By following these best practices, using clear naming, optimizing for performance, and writing thorough tests, you can create directives that are a joy to use and maintain. Now we will cover some common mistakes and pitfalls to watch out for when working with directives in Angular. First and foremost, one of the most common mistakes is forgetting to declare your directives in the module or component where you want to use them. If you forget to do this, Angular won't recognize your directive and you will get an error in the console like this. To avoid this, make sure to always add your directive to the declarations array in the module or in the imports array of the component if you are using standalone components. Like we did here. We added these directives in the imports array because my component was standalone. But if you are not using standalone components, but you are using modules, you can declare these directive components in your relevant module. Another common pitfall is incorrect usage of the input and output decorators. Remember, input is for properties that you want to pass data into your directives, and output is for events your directive emits. So here is an example of correct usage. A mistake I often see is people forgetting to add the decorator or using input for an output property or vice versa. Double check that you are using the correct decorator for your purpose. Performance is another key consideration when creating directives. Excessive DOM manipulation can lead to performance issues, especially in directives that are used frequently. So here is an example of excessive DOM manipulation. To mitigate this, try to use host binding instead of direct manipulation when possible. Batch your updates and avoid unnecessary updates like this in my screen. You can see I have used the host binding, and now on mouse enter we are accessing that style from the host binding from the host, and we are updating all of the styles all together in one go. So finally, let's talk about debugging and troubleshooting directive issues. If your directive isn't working as expected or you are seeing errors in the console, here are a few things to check. First one, is the directive declared in the module or imported in the standalone component? Is the selector correct? Are the input and output decorators used correctly? Can you track the flow of data with console.log statements? Here is an example of debugging with the console.log statements. You can also use the Angular dev tools for debugging directives. They provide a lot of useful information and insights. So this is the Angular dev tool that you can see. It is also mentioned in their documentation as well. So you can review it and follow it. So they have shown you the example how to use it, and it is very convenient and powerful. So this is the Chrome extension that you can install and you can start using it. So this is official extension by the Angular. Okay. Now let's wrap up with our conclusion. In this tutorial, we have covered a lot of ground and we have learned what directives are and why they are important in Angular. We have explored the three types of directives: components, attribute directives, and structural directives. We have seen how to create our own custom attribute and structural directives, and we have discussed the best practices for directive creation and usage. But learning about directives is just the beginning. The best way to truly master directives is through practice and experiments. I encourage you to take what you have learned here and apply it in your own Angular projects. Create custom validation directive, build a reusable tooltip component, experiment with creating your own structural directive. The possibilities are endless, and the more you practice, the more comfortable and proficient you will become. If you want to dive deeper into directives, there are plenty of great resources available. For example, the Angular documentation has comprehensive guide on directives. Learning directives is a big step forward in your journey to mastering Angular. But remember, there is always more to learn in the ever-evolving world of Angular development. Keep exploring, keep experimenting, and most importantly, keep learning. As someone said, the journey of 1,000 miles begins with one step. You have taken that first step in mastering directives. Now keep walking and enjoy your journey. Thank you for joining me on this deep dive into Angular directives. I hope you have found it informative and inspiring. If you think that this video really provided you value and helped you, then please don't forget to subscribe to my YouTube channel and click on the bell icon to get notified for upcoming videos. And also please like and share this video. If you have any questions or thoughts or feedback or suggestions, then please leave them in the comment section. I would be happy to reply them as soon as possible. Until next time, happy coding. Goodbye.